Hello everybody, welcome to IB Buddy Grade 9 Mathematics. Today we're going to be talking about rational numbers, also known as fractions. So what are rational numbers? They're any number that can be expressed as a fraction. So like 1 over 3, 5, which can be expressed as 5 over 1, which in this case, in fractions, this line means division. So then 5 divided by 1 is 5. Here, 0.1 can also be a rational number because 1 divided by 10 is 0.1. So why do we use fractions? Why not just use decimals? So this is because calculations can stay exact instead of being distorted by calculations. So for example, we have 1 over 3. So that equals 0.33333, and then 3 keeps on repeating infinitely. So if we just simplify this by just taking this, let's just say 0.33, right? You completely change the number because it's supposed to be 0.3333333 all the way until infinity, but you just made it 0.33. And we can see this as 1 over 3 is 0.33333 like infinitely, and 0.33 equals 33 over 100. And you see 33 over 100 and 1 over 3. They do not equal the same. They are not the same. So that's why we use fractions to preserve that number, that value. So now that we know why we use rational numbers and fractions, let's talk about how to add and subtract them when they have the same denominator. So for a little hint, this is the numerator, the top portion, and the denominator is the bottom portion. So when adding and subtracting denominators, you want the denominator the same number. So here you can see 9 and 9. You see here that here you see 9 and 9. You see both denominators are the same. So all you have to do is focus on the numerator. So here we have 4 plus 8. So 4 plus 8, that's easy, 12. Now, in adding and subtracting, we just keep the denominator the same. So here the denominator is 9. Okay, over 9. And there you go. You have the fraction. Or so you think. Because now you want to simplify the fraction if you can. So what do I mean by simplifying? I mean finding the greatest common factor and dividing both the numerator and the denominator by it. Okay, wait. So hold up. Wait a minute. What is GCF, the greatest common factor? So the greatest common factor is essentially the biggest number you can divide a number by without it turning into a decimal, right? So if you divided 9 by 4, right, that would turn into a decimal. But if you divided by 3, it wouldn't turn into a decimal. It would be 3. 9 divided by 3 is 3. So what's the greatest number that you can divide both these numbers by? So here we see, okay, let's see 12. So 12 can be divisible by 4. But 9 divided by 4, that doesn't equate to a whole number. Okay, wait. Let's try 3. 12 divided by 3 and 9 divided by 3. Wait, that actually works. And that's because it is the greatest common factor. It is the greatest value both numbers can be divisible by to equate to a whole number. So 12 divided by 3 is 4 over, and then 9 divided by 3 is 3. So now you get your answer, which is 4 over 3. That is your answer. So always, once you complete your fractions, always check, can I simplify this further? All right, now let's go on to subtracting. Subtracting with the denominators the same. So you can see 4 and 4, they're both the same. So all you have to do is the same as addition. look at the numerators, 1, and then see what is it being added or subtracted. Here it's being subtracted, and then look at the other one, 3. So 1 minus 3. That's easy, -2, right? -2 over, and then also in subtracting, look at the denominator. And so here it's 4, so you just put 4 there. Now here, you can put the negative sign either like this, -2 over 4. -2 over 4, like that. Or you can put it where the numerator is. It doesn't really matter. The only thing that matters is you can't put the negative sign on the denominator. If the negative sign is on the denominator, always transfer it to like either here, the middle place, or transfer it here to the numerator. It doesn't really matter as long as it's either here or here. Never in the denominator, never. Right? So now that you have -2 over 4, you can simplify this even further. So the greatest common factor here would be 2. So 2 divided by 2, that's 1. And then 4 divided by 2, that's just 2. So that would equal -1/2. Now let's do addition, but the denominators, you can tell, are not the same, right? So what do? You want to make the denominators the same without turning them, obviously, into decimals. You do not relate fractions into decimals. But here, just simple fraction addition, all you have to do is find a number that we can multiply by or divide by that will give us the same denominators. So here we can divide 6 by 3. Make sure whatever you do to the bottom, you always do to the top. So if you're dividing the denominator by 3, you also divide the numerator by 3. But you see how 5 divided by 3 gives you decimal. So no, we can't do that. What's another way? Ooh, what if we times the denominator by 2, and then whatever you do to the bottom, you do to the top. So then 1 times 2. Wait, that actually makes sense. Because now 1 times 2 is 2. It doesn't give you decimal. So that's good. 5 over 6. Because you don't do anything to this fraction. Because we already have 6. Plus, and then 1 times 2 is 2. And then 3 times 2 is 6. Boom. Now we have the same fractions. Now you might be thinking, oh, let's just simplify this. No, because here we're trying to get the same denominator to add and subtract. In fractions, you want the same denominator. So you always simplify at the end once you found the answer. So here we do the same now. Since we have the same denominators, you do the same. You grab the numerator, look at what is it being added or subtracted, and then you get the second denominator. So 5 plus 2, easy, 7. And then keep the same denominator as always, 6. Boom. Now, same thing with subtraction, right? So you want to find the common denominator here without getting decimals. Here, it's 42. So how do we get both denominators to 42? We can times 7 by 6. Whatever you do to the bottom, you do to the top. And we can times 6 by 7. And then whatever you do to the bottom, you do to the top. So here, 5 times 7, that's 35. 6 times 7, that is 42. And then minus, always keep that the same. And then 3 times 6, that's 18. Over, and then 7 times 6, that is 42. Now we have the same denominators. Hooray! And now we can just do basic subtraction. 35 minus 18 is 17. Over, and then always keep the denominator the same, 42. And now see, can we simplify this even further? No, we can't? All right, we're good. Now let's go on to mixed fractions. So IB prefers improper fractions, and also improper fractions are much more simpler. So you're like, what are improper fractions? Improper fractions are when the numerator is bigger than the denominator. So like normal fractions would be like this, 2 over 3, 1 over 2, stuff like that. But when the numerator is bigger than the denominator, it's like 9 over 4, 3 over 2. Like you see how the numerator is bigger than the denominator. So to convert mixed numbers where we have one big number and then a fraction, a whole number and a fraction, what you do is first you look at the denominator, 5, okay, and then look at the whole number, the big number, right, 1. Now what you want to do is multiply them. So 5 times 1, that's 5. So now you have 5. Now what you want to do is look at that 5 and look at that numerator. And what you want to do is just add them. So add them. So 5 plus 4, that is indeed 9. So we just have 9. And then we keep the denominator always the same, which is 5. So 9 over 5. And that's how you just transfer it into improper form. So, and then we keep the addition. And then we do the same. 3 times 2, that gives us 6. And then 6 plus 2 is 8. So we get 8 over 3. Now we do the same addition. So we see that we don't have the same denominators. So we have to find a common denominator. So we see here we can times 5 by 3. And whatever you do to the bottom, do to the top. And we can times 3 by 5. And whatever you do to the bottom, you do to the top. And you see that the common denominator is 15. So to get 15, we do 5 times 3 and 3 times 5 to both get 15. So we just do this, 9 times 3, which is 27, over 5 times 3, 15, and then plus, and then 8 times 5, 40, over 3 times 5, which is 15. Now we have the same denominators, and then we can do the same addition. 27 plus 40, that is 67 over, and then you have the same denominator. When you're adding fractions, always have the same denominator, which is 15. Boom. And now, can we simplify this even further? No, we can't. All right. Now let's go on to multiplying fractions. It's much more simpler. So first, we see we have a mixed number. So let's convert that into an improper fraction. So what we do is we do 5 times 2, that's 10. And then 10 plus 2 is 12. Over, and then keep the denominator the same, 5. And now, for multiplying fractions, all you do is straightforward. You find the numerator and times it by the denominator. Find the denominator and times it by the other denominator. And it's really just straightforward. You don't need the same common denominator. These denominators are different, but you can still do it, right? So you just do 1 times 12, that's 12, over, and 3 times 5, that's 15. You realize that these aren't the same denominators, right? You don't have to set them the same. Multiplying fractions, you just multiply the numerators by the other numerator and the denominator by the other denominator. So we have 12 over 15. So can we simplify this? Yes, we can. We can simplify this even further by the greatest common factor here would be 3. So we can divide this by 3 and divide this by 3. And so 12 divided by 3, that would be 4. And then over 15 divided by 3, that is 5. So that gives you your answer, 4 over 5. Can we further simplify this? No, we cannot. Now let's go on to dividing fractions. So we have 2 over 3 divided by 7 over 15. So what we do when dividing fractions is first take this sign, right? We have division. Make it times. Now grab the second number, right? And what you do is you just flip it. So you put 15 on the top and you put 7 on the bottom. So it would be like this. So you would have 2 over 3, right? Keep the first number the same. And then flip this. The opposite of division is multiplication. And then flip this around. 15 on top, 7 on the bottom. So it'd look like this. 15 on the top, 7 on the bottom. And now you do normal fraction multiplication. 2 times 15, that's 30. And then 7 times 3, 21. And can we simplify this even further? Yes, we can. The greatest common factor here is 3. So we can simplify this 3. So then 30 divided by 3, that's 10. 21 divided by 3 is 7. And there you get your answer, 10 over 7. Now we're gonna combine everything we just learned so far. So remember, these lines always mean division, right? So we have 5 over 2 minus 1 over 6 times 7 over 3 minus 1 over 2 over 3. So we know we have to do BEDMAS, right? Brackets first. And we know that to subtract, right? We need this common denominator. So here what we can do is we can times 2 by 3 to get 6. And then what do we do to the bottom? Do to the top. And this is already 6, so you don't have to do anything. So that would be equals 5 times 3, 15, over, and then 2 times 3 is 6. And then keep 1 over 6 the same, because we already have the denominator as 6. And now here, brackets again, 7 over 3, okay? But you know that in whole numbers, it's always the whole number. This thing is at the top. And then secretly, which is hidden, the denominator is 1, always. Like, if you have 2, the fraction equivalent is 2 over 1. It's always the whole number goes on top, and then it has a secret 1 on the bottom. So, because, like, if you have 2 over 2, right? If you put into a fraction, 2 divided by 1, that equals 2. So, that's how you get it. So, now that you see this, you want to get the denominators the same, because you see it's subtracting and the denominators are not the same. So we want to find the common denominator. So we can see we can times this by 3, and then whatever you do to the bottom, you do to the top. So then we just keep this the same because we already have the denominator of 3. So 7 over 3 minus, and then 1 times 3 is 3. And then here 1 times 3 is 3. All right. And then remember, when you have to solve on the top and there's also like something on the bottom, you have to do them separately. You have to solve first the top and then solve the bottom. And then this line means division. So you divide both of them together. But here you can see that the bottom, we don't really have to solve for anything because it's already like simplified. It's already the simplest form, 2 over 3. So you just write 2 over 3. All right, now we do 15 over 6 minus 1 over 6, which is the normal subtraction. So 15 minus 1 is 14. So we just do 14 over, and then keep the denominator same for subtraction and addition for 2 over 6. And then we have the denominators the same, so we can do normal subtraction. 7 minus 3, that gives you 4. Always keep the denominators the same for addition and subtraction, so we just get 3. Over, and then 2 over 3 stays the same, 2 over 3. Now we just want to multiply these together. So 14 times, because we're doing now multiplication of fractions. So all you do is multiply the numerator by the numerators and the denominators by the denominators. You don't need to find the common denominators, remember. So 14 times 4, that gives you 56. So you do 56 over, and then 6 times 3, 18, over 2 over 3. Now, we can simplify 56 over 18 further, right? Because these two, remember, are separate. They're separated by this line. So we have to first solve the top and then solve the bottom and then divide them together. So the greatest common factor is 2. So divide this by 2, divide this by 2. So 56 divided by 2 is 28. Over 18 divided by 2, 9. And then over 2 over 3. 2 over 3. And now, can we simplify this even further? No, we can't. Can we simplify this even further? No, we can't. So now, remember, this line means division. So it's essentially saying 28 over 9 divided by 2 over 3. And this is essentially just dividing fractions, which we learned about. We keep the first number the same. The opposite of division is multiplication. So we times, because we flipped this sign around. And then we flip this fraction around. So it would be 3 actually on the top and 2 on the bottom. And then you do regular fraction multiplication. 28 times 3 is 84. Over, and then 9 times 2 is 18. Now, is this the answer? No, it isn't. We have to simplify this. Can we simplify this? Yes, we can. So the greatest common factor we can see is 6. So we can divide this by 6, divide this by 6. So 84 divided by 6 is 14. Over 18 divided by 6, which is 3. And now, can we simplify this even further? No, we can't. So this is our answer, 14 over 3. So thank you for choosing IB Buddy. We've learned how to add and subtract fractions, how to convert mixed numbers into improper form, what are rational numbers, why are they important, how to multiply and divide fractions, and how to apply them all together in like one sort of master equation. Thank you for choosing IB Buddy. See you tomorrow.